Richard into the stream now. Richard, welcome.
Hey, how's it going?
Going very, very well, thank you. And you?
Fantastic. Yeah. Good. Having fun.
And Richard, you're a very humble guy, which is why you have a 6-foot picture of yourself in the background there, I can see.
Absolutely. If someone makes a 6-foot poster of you, you have to keep a hold of it, right?
You take it and you put it in the bedroom like any reasonable Excellent. So, Richard, we've known each other for, probably a decade or so now, from the London Java user group, and you did a lot with the virtual Java user group as well. You're a Java champion. You're the CTO and founder of Option, which is a performance tooling company. You're a lead developer of the high-performance RTO fix engine, Pluralsight trainer, and a whole bunch more. Author, I'm sure, as well, right? Which book did you do? Was it a Lambda's book?
I wrote Java at Lambdas. I wrote another book with Raoul, which is conveniently located here.
Look at that. Just next to your 6-foot poster of yourself. That's amazing.
A grade, yes.
Wow.
Yeah.
Excellent. Well, Richard, it's an absolute pleasure to have you on. And thank you very much for being here. Just so that everyone online is aware, this is a conference which is a little bit different. We're raising money for an amazing cause, the COVID-19 pandemic, trying to help victims and families get back on their feet there. We've raised over $70,000 so far, and we are still going. So please do phone this hotline number. We'll put it here for the recording. No, seriously, do go to allthetalks.org/tickets, and you can go and donate as much as you can, or as much as is reasonable. So thank you very much. And Richard, what I'll do is I'll add your screen in there, and I'll let you take it away. Thank you, Richard.
Thank you very much, Simon. As Simon was saying, I'm going to be talking about continuous profiling production, what, why, and how today. So in this talk, we're going to cover a few different things. Firstly, we're going to talk about performance tooling and why you want to look on the kind of problems that performance tools can solve and the insights they can give you. And we're going to talk about the distinction between measuring problems in a development versus a production environment, because often people use performance tools like profiles and things in a development environment, and actually they can often be more useful in a production environment. Then we're going to look at the different information that you can get out of a production system, so metrics and profiling and logs and all sorts of different things. And then we're going to look at continuous profiling, what that is and how it can help people, and draw some conclusions. So firstly, when we're thinking about, a lot of things to do with our software system, architecture, development, we can kind of think of 3 different classes of problems that we see with regards to an application. Firstly, there are your known knowns. So these are things that you know are going to be a problem ahead of time. You can prep for them, you can plan for them, you can architect around them. For example, that main memory is faster than, say, disk access, at least if you're on spinning Rust and things. Certain key characteristics about your setup like that. Then there are your known unknowns. So these are things where you don't necessarily know the details in advance, you don't necessarily know they're there, but they're problems that you could plan for, you could brainstorm, you could think through. You don't know what the exact ratio, for example, between memory and disk I/O actually is, but that's a ratio that could differ on different production environments. And for example, that you might want to test these kind of characteristics when, say, for example, moving to a different data center or moving to a different cloud instance. Then there are your unknown unknowns. These are things which, maybe if you knew they were a problem in advance, you could plan for, but in practice, they're the things that you don't think about, the things that you aren't necessarily aware of beforehand. These are things that will really kick people there. For example, you've got some nice fancy parallel algorithm, you've done your big O analysis, and then you don't realize that you've got some logging system calls in the middle of this nice parallel algorithm. There's a big lock in your logger, and it's slowing everything down. These are things that you don't really know until you go live with a real production system, and they're things that you can only really understand from the real world. You can't necessarily theorize or hypothesize about, no matter how smart you are. So when people look at solving problems and working and improving their product, they often think in terms of their development environment. So that can often be very productive. We run automated tests in our IDE, we can get IDE tooling, people can help solve security problems in a development environment now. Lots of fantastic stuff out there. But for performance problems, development and production are very, very different worlds. And in practice, if you measure things in your development environment, you will see different problems to production. There's a few different reasons for this. Firstly, there's the unrepresentative hardware problem. So in practice, machines that people use for their data centers, production systems are often very, very different from the kind of machines that they develop on. So, for example, you may be developing code on a laptop, you may have a workstation machine, but you're very unlikely to have more than 8 cores on that machine. Even if you've got a pretty beefy desktop machine like the one I'm using to present this on, you're only going to have about 16 cores probably. Servers these days can have 64, 128 cores, a lot, and they can be very, very different types of CPU as well. Often big Xeons with bigger caches and sometimes lower clock speeds. In practice, just because things perform well on your laptop, it doesn't mean you're going to hit the same performance problems as on one of those big workstation machines. You can get lock contention problems, which are visible with many, many cores, that are not very visible when you've just got a few cores. You can have different ratios of CPU and disk I/O rates that shift your performance differently. And if you're using a modern cloud environment, often those small micro instances and function as a service platforms can actually be way, way slower than your development environment. Then there's unrepresentative software. In practice, most people deploy their software stack onto, say, a Linux operating system in production. They may well be running on top of a virtualization layer. They may well be running on top of Docker within that virtualization layer. All sorts of things going on there. In development, they may well be running Windows or Mac OS that have completely different scheduler systems, different I/O subsystems, different network stacks from Linux, and perform very differently. And Linux isn't always faster either. And again, as we say, different ratios of different performance characteristics shift where your bottlenecks are. Even running a different version of the same operating system can cause very, very different performance characteristics. Back in May 2015, there was a regular patch Tuesday update for Windows that tanked UDP throughput by 40% on some benchmarks I was running. And that was just for one of those Spectre meltdown mitigation things, I think. But these performance characteristics can be very big. And finally, it's the workload. This is the hardest problem to solve, the biggest differentiating factor between you trying to replicate and diagnose a performance problem in your development environment and a real production system. If you have different numbers of users hitting your system, if you aren't necessarily running a system that is dealing with a lot of network traffic towards other services in your development environment, maybe you're running them on Docker images on the same box versus running on different hosts in production. If you're using your different load harness, a different type of load on the system, you can get very, very unrepresentative workloads. You can be hitting wrong pages. You can be you can have things that look like they're in cache a lot in performance tests when in real production systems they aren't. You can get things where, for example, with lots and lots of users, you might not have your user data in cache in a production system, whereas you might with just testing with one user. It's very, very, very hard to get in synthetic performance tests to replicate your production environment. And even if you do get it, that's not the end of the story. You have to maintain that as your users change their behavior, as your system changes its behavior. As you add more features, you have to add performance tests for those. In practice, performance testing well and effectively can often be so hard that many organizations don't even bother. In short, you need to measure the right thing, okay? If you measure the wrong thing, you will fix the wrong problems and you will not be able to spot and rectify real performance problems, real performance bottlenecks that cause actual outages for your production system and problems there. Okay, so we said you don't want to look at your development environment to understand the causes of your performance problems. Where do you want to look? Production. But what information can you actually get out of production? Production has a different characteristic. Extracting information from production has to be very low overhead, because the higher overhead it is, the more it slows your system down. The first type of information that people get from their production system are metrics. So these are pre-configured numerical measures. These are just like a series of numbers in a time series that evolves over time. You can get things like CPU time usage, breakdown between user, system, disk I/O rates, all sorts of things like that, to understand what your system is doing, your page load times, memory consumption. Metrics can be very, very useful. They can be very, very cheap, very low overhead to gather that and pull it out of a production system. And sometimes they can be very effective at narrowing down where performance problems are, where bottlenecks are in your system. But the problem with metrics is that you often end up in one of those murder mystery weekend investigations. Now, these things sound very fun. And, if you've ever seen a Hercule Poirot show or read one of the books, you'll know that they can be exciting. He goes around and says, were you the murderer? Were you the murderer? And it's always the last person you look at who turns out to be the murderer. And you get the same kind of situation with metrics. Often people try and measure every single metric under the sun because they want to know everything. But then when they're actually trying to look for a performance problem, it takes them a long time to find the resolution, because they start scanning through and looking at these different metrics to see what is way out of band today, what is unusual. And often, if you measure a lot of things, you can find correlated failures. So it can not be necessarily obvious which metric is the real problem here. Brings us to logging. Logging can be incredibly useful for extracting information from a production system. Arbitrary events emitted by the system being monitored. So slog for J, slf for J, log back, log extraction systems, log aggregation systems, often very, very useful. I don't want to say any of these things are necessarily bad individually. The problem is that if you really want detailed events being emitted by the system, it's often very manual, often a lot of work that your developers have to do. Sometimes people have whole teams building observability platforms around instrumenting and emitting logging events. Can be very detailed, can aid system understanding, can give you a cause that metrics don't necessarily give, but there's a lot of overhead there, and you have to be very careful that your logging systems don't become the bottleneck in and of themselves, which I've seen on so many people's production systems. There are also logs for more specific events, so garbage collection logs, for example, tell you about events within the GC subsystem. Super useful, quite low overhead actually for GC logs, but very, very niche understanding. If you want to do GC tuning, very, very useful. If you want to look at other areas, maybe not so useful. Then there's coarse-grained instrumentation. This is the kind of instrumentation that most application performance monitoring APM tools provide. So they take the start time and end time of an operation of a method, and they subtract one from the other. You take the time that operation took. That code that you're adding is called the instrumenting code or instrumentation. The key point about instrumentation is it can be very detailed. It can give you vectors into your code base that let you understand where that problem is. But it can also be very overhead. It can also be very heavy in terms of overhead. The more detailed your instrumentation is, and the more actionable that instrumentation is, the more it tells you more specifically what the problem is, the more overhead there is to running it. But it's perfectly good for things like how much time do you spend inside the control layer of your web app, or how much time do you spend performing SQL queries. Production profiling. What's production profiling? Profiling is a very general method for telling you what is the dominant consumer of a certain resource or a certain type of event within your system. So what methods used up CPU time? What lines of code allocated the most objects? Things like that. Profiling is automatic. So you don't need to tell your profiler anything about your application or an instrumentation. It can just if you can profile a JVM app, you can profile a JVM app. It can be made very, very cheap. It can be made to be very, very low overhead. But often, a lot of profilers, especially profilers designed for a development environment, are not low overhead. They slow down the application under profile by quite a lot and are thus not usable in production. And we really want profiling that works in production. We'll talk briefly later on about the kind of profilers that are low enough overhead that we can use them in production. Another problem that instrumentation is challenging, another problem that is a challenge for instrumentation is the factor of instrumentation needs to be added a priori before a problem happens. And if the person who designed that instrumentation system didn't think about your category of problems, you'll be blind to them. Not only bigger overhead, but it's kind of assumption-driven, hypothesis-full monitoring approach. So we had a customer, for example, at Opsian, who had a problem. Every 5 seconds, they had a certain HTTP endpoint. It would be really slow. It wouldn't respond to any requests for a couple of seconds. They had an APM tool in place. It had instrumentation. And they looked at the monitoring dashboard for that APM tool. It didn't even show the pause. The APM tool said, look, everything's fine. Your system's going really fast. But their users could definitely see the slowdown and were being frustrated by it. Now, the problem here was that the instrumentation was on the servlet request, so it only looked at how long it took to process a servlet request. It didn't look at the bigger picture, the system view, the Gestalt view. The root cause here was that Tomcat was expiring its resource cache every 5 seconds. So every 5 seconds, it would go and talk towards a resource and say, do you want to, update things here? One of those resources wanted to go and scan their entire class path, which was pretty big. It would pause the whole system for a couple of seconds. So that's the kind of thing that can be easily spotted within seconds of looking at a profiling view. What? We're spending all of our time reloading classes and scanning the class path? We weren't expecting that at all. But it's something that if you don't think about ahead of time, other metrics and instrumentation wouldn't necessarily show. Okay, so let's talk about continuous profiling. Firstly, how do we use continuous profiles? We want to extract a time period or your application's machines that you have a performance problem or that you want to look at. Pick an event to profile. Profiles are about measuring certain events, counting certain events. View the results of what the dominant consumer of that resource, of that event is. So what was the thing that was really the bottleneck? What was eating the resource up? Fix that bottleneck, preferably only one bottleneck. If you've got a nice modern DevOps system can redeploy rapidly, better to fix a bottleneck, redeploy, remeasure, and do it scientifically, change one thing at a time. Profiling can measure all sorts of different types of events from your system. You can look at CPU time or wall clock time. We'll look at time in a second. You can look at things like memory allocations. What is eating up the memory on your heap? What is allocating lots of objects? And you can look at things that are more esoteric or obscure, like cache misses and cache hits, all sorts of stuff like that. So I mentioned these two different types of time, CPU time and wall clock time, because I think it's often very confusing for people when they look at profilers. CPU time is the actual time that you spend on CPU executing instructions. And wall clock time is the begin to end time of your actual operation. I, as somebody who's addicted to coffee, like to think of this in terms of a coffee analogy. Now, if you go to a good coffee shop or even a Starbucks at lunch, you'll find that there's a big queue outside the front of that cafe. And there are people waiting in that queue. The time it takes you to get your coffee from beginning to end, waiting in the queue, paying the barista, taking your order, making the coffee, queuing the other side of your coffee to pop out, well, that's your wall clock time, the begin to end time on the operation. CPU time is more like the time that the barista is spending actually making the coffee, taking people's money, the time actually doing stuff. If you want to understand a wide range of performance problems within your system, you need to look at both CPU time and wall clock time, okay? CPU time can help you diagnose computationally inefficient bottlenecks and hotspots. It can let you see code that shouldn't be executing, that's actually taking up loads of time, like our aforementioned example of the Tomcat class path scanning type stuff. It also is scaled by what is actually running on CPU over time. Wall clock time, however, diagnoses blocking problems that stop CPU usage. Off CPU profiling is related here as well. So, for example, if you've got a fancy microservices set up and a lot of your time you just spend waiting to get data back from other services, that's what wall clock time can help you with. If you spend a lot of time reading or writing from disks, that will show up in Wallclock time, waiting on I/O. And lock contention systems with issues within your system where you've got lots and lots of threads all trying to get control of a hot lock, they will be visible with Wallclock time profile. That is very, very useful. And not every system offers Wallclock time-based profiling. Profiling information can be visualized in a range of different ways. So firstly, there is a hotspots view or a flat profile view. So that's just a list of methods within your application, and they are sorted by what uses up the most amount of time, or the other resource that you're measuring. Good profilers will also let you see what the line number is for those profiling hotspots, which parts of the methods are really hot, which can be super useful in big, large methods if your colleagues have unfortunately left you with those methods. They can also give you nice long stat traces that tell you what was calling those methods when they were hot. A more modern, more hip, more useful visualization of profiling data can be found with Flamegraphs, okay? So Flamegraph is a visualization where every method in your system is a box. They can go top down, like this one is, sometimes called icicles, or bottom up, the more flamier view of Flamegraphs. In this top down view, every box is calling its children below it in the graph. So java-lang thread.run, which is the top method in this visualization, is calling the NIO endpoint $acceptor.run method inside Tomcat, and that's calling down into a Tomcat stack. The width of the boxes within Flamegraphs visualize how much time roughly was used by a given method within your system. So wider boxes are saying that this uses up more time, but it's not just that method, it's that method and its children that use up time. So when you're interpreting Flamegraphs, you want to look for the points where the graphs narrow down, where they've got children that are narrower than them, rather than just looking for fat boxes. Flamegraphs are very good for visualizing profiling data in context. Earlier I said many desktop profilers are not suitable for production profiling. It's completely true. Hooking JVisual Beam up to production can result in you having a bad time. Advanced statistical profiling is the way forward. In 2020, you can get accurate, very, very low overhead profiling data. Pretty much all the profilers that work like this have the following characteristics. They use operating system signals, like SIGPROF, for example, SIGAlarm, to send signals periodically to different threads within the system. They use that to interrupt the thread as it's operating and then capture stack traces at that point in time. Or they can get allocation data and capture stack traces on certain allocations as well. Traditional approaches are too slow, but this works very, very effectively. I don't want to go into too much more detail because it's quite a short talk, but there's lots of information online about this kind of stuff. And it's an approach that you see increasingly effectively adopted in different ecosystems. The Java JVM world, we have things like JFR, Async Profiler, and Honest Profiler. Ruby, RSpy, Python, PySpy. The native code ecosystem has Perf if you're running on Linux, and Go has pprof. These are low overhead ad hoc profilers. So what I mean by ad hoc, well, they aren't profiling all the time necessarily. They're still in that desktop mode. They're still in that mode of you've got to connect up to a production system. What we want to do is think about profiling all the time. So historical data gives us the ability to look at things that have happened in the past. Your outage was last night. What was the profiling data from last night? It lets you correlate with other data and metrics. You saw really high load yesterday afternoon. Look at the historical data for that time period. It also lets you do performance regression analysis. You release a new version of your software, just look at the diff in profiling view in your profiler between the current version and the previous version of your software. That is continuous profiling, taking data from different agents, different systems out there, aggregating them in a common service that lets you query over that historical data, understand that historical data, and process that historical data, and having a modern web-based report, not a traditional desktop profiler that you have to connect into the system in question and manually tweak around with things in order to see what's going on. That doesn't work when you're running hundreds or thousands of different services in production. It doesn't scale up, and it also requires you to do things like break glass and try and connect into production systems. When you're having a stressful, high-risk outage, you want to have these things set up in advance. Okay, so 2 minutes left. Let's time to draw some conclusions. We think an option that you need to really take a real attitude shift on profiling and monitoring. We all can do so much better on this front. We really can. So there's 3 different parts of that. Firstly, thinking about performance problems in a systematic way, not an ad hoc way, having a performance diagnostic methodology, knowing what the relationship between different metrics are that let you root down to different causes, and having the right systems in place in order to be able to understand things. Being proactive, not reactive. That doesn't mean doing premature optimization within your software system. What that means is having the right tooling and systems in place that you can measure what's going on with your production system, that you can performance tune, you can performance optimize, and also really considering these things as being a business value win. Customers genuinely are often far happier with a fast system than a slow system. And there's a bunch of A/B tests out there by the likes of Google and Amazon showing that you get more business and more customer retention with a fast system. In order to do that, we need to be continuous. It should be part of your standard build and deploy to have monitoring and profiling data in there, stuff that will let you see what is causing you performance problems, outages, and bottlenecks very rapidly, and just in there as part of your normal build, not something that you necessarily need to have a one-off break glass ad hoc measure to understand. In short, if there's one takeaway from this talk, please do production profiling all the time. Obviously, at Option, we are a continuous profiling company, so our tool will help you achieve those kind of goals, but we really want you to try and do this continuous profiling regardless of whether you use our tool or not. It will really be something that helps you get a more reliable, more performant, and more enjoyable production environment. And on that note, we are at the end of the talk. It's time for questions, Simon. Do we have any questions?
Richard, so if anyone has any questions, please do ask either within the Slack group, or of course you have the Slido in next to the video in live.alltalks.org. So please do ask questions there. Richard, do you presumably you do profiling at Option?
Yes.
What's your preferred method? Do you do any performance testing earlier? I get that it's not like more a tuning kind of thing, but do you do any performance testing in development as well as production? And do you prefer instrumentation, sampling, or a bit of a mix?
So for finding our production performance problems, we pretty much found everything through either profiling or looking at some metrics. We don't run any real instrumentation-based stuff on our own production systems. The other part of that question was performance testing, right? We do certain performance testing for certain algorithmic bits. So we've got a back-end data storage system where we've done certain key performance testing stuff before we rolled it out, just to see if it was roughly on ballpark. But we never assumed that was going to be like the absolute perfect ahead of time load test. And obviously, over time, since we deployed that code into production, we've seen real profiling data back from it from our own profiling service, and we found things that we would not have spotted ahead of time. Trying to think of a good example off the top of my head. So one of the things that we spotted was that people were doing different patterns of querying in our production system that basically hit different parts of our system to the way our load test did. So we had to basically do a little bit more optimization for certain paths that we didn't think were going to be that hot when actually they were hot.
Gotcha. Cool. Question from Anonymous in Slido. Really good question. How can I? And I think this has a lot of weight across a number of different items. But specifically performance as well. How can I sell to my boss the idea of profiling to be allocated both time and budget?
Yeah, that's a fantastic question. So for customers that we've talked to who found real benefit from this kind of thing, you often find if you're doing any kind of cloud deployment that you have low-hanging fruit within your system that can be easily optimized away, that will often give you a cost win that is pretty much bigger than a continuous profiling service will cost. So you can often get easy performance wins in that way. We often find that looking at some of those A/B tests that people have used can be very useful. So Google, for example, did an A/B test and showed they had 20% traffic drop off on their search page if they added half a second of load time latency, right? So slowing down search page results lost them 20% of their traffic just by half a second. Amazon have published another A/B test where, for example, they showed they would lose, if they generalize their A/B test, $1 billion a year in revenue from, again, just adding half a second to page load times across Amazon.com. So if you've got stuff that's very customer facing, customers are often, I don't want to say impatient, but we all want to get stuff done, right? We're busy. We don't want to be sitting there waiting. It's a frustrating experience. It's a real nightmare. So customer retention is really important. Cost reduction is really important. And the third aspect of it is really developer productivity. Often you can fix performance problems, but those people who are your colleagues can often be very, very expensive, like a lot of software developers. So if you can use their time more effectively, if you can just say, hey, click a button, here's the result, or not the perfect solution, but so much of the work done for you, it's much more useful for those people rather than them having to go out there and spend a lot of their expensive human capital in solving those problems.
Awesome. Richard, this is awesome. There's also another question, but I'm going to ask for that to be taken in Slack just because we are a couple of minutes over.
Okay.
And we have our next speaker. So, Richard, a big thank you from everyone at all the talks. And,
thank you very much. And
awesome session.
Thanks for organising everything as well. It's great.
No worries. Pleasure. Awesome.